this, and I will be posting this on the Innovate Bio website probably this weekend, so it'll be there Monday for sure. And I'll put a note about it in the newsletter as well. And as you know, today we are going to be talking about the BioSCOPE grant and the supply chain work for biomanufacturing that's come out of this. Before we get started, I have one quick announcement. That is December 2nd, we are going to have a community conversation, and we'll be talking about the data that's on the Innovate Bio website and how to make use of it, and how you can help us with entering that data when you work on your program page, and how you can make those program pages work to your best advantage. Because we've had programs who've gotten students because of what they read, the information that they read on their BioLink and Innovate Bio program pages. So it's good to think about what information you have there and what that says about your program and how that can help you. Okay, so without further ado, I would like to introduce Dr. Ying-Tsu from BABEC, and also a former professor from City College of San Francisco, and Dr. Terri Quenzer from Miracosta College. And I'm playing whack-a-mole somewhat here with letting people into the talk. So why don't you guys go ahead and tell us what you got?
Great. Do you want to share your screen, Ying-Tsu?
Yep. Here we go.
Perfect.
And do you want me to put it on slideshow?
Yeah. That'd be great.
Exit first. Get to the first slide. Okay.
Okay, first of all, I want to thank you for joining us today. We're really excited to talk to you about the BioSCOPE project and BioSCOPE 101, which was formerly the Supply Chain Guidelines project, and I'll explain a little bit more about that as we get going. So next slide, please. First off, as I mentioned, we did change the name of this, and that's because it's expanded. So it's more than just a small guidelines. So BioSCOPE 101, and BioSCOPE stands for the Bioscience Supply Chain Operations Projects for Education. And BioSCOPE is the acronym, and so BioSCOPE 101 is the name of the manual that'll help you to use BioSCOPE. So next slide, please. So before jumping into what BioSCOPE is, let's just talk about what supply chain is. And the most basic definition of a supply chain is just transforming raw materials into some sort of final product that could go out to customers. And in our case, we're focused on biotech-related projects. And so we have students that actually use biotech to manufacture their products, and then those products, the students follow quality and documentation and compliance, and so those products go out to their customers. Next slide, please. But we also look at supply chain from another perspective, and we look at it as pathways, because if you go back to the definition I just mentioned of starting with raw materials and transforming those into a finished product, that's what we do with our students. We get our students that have little or no skills, most of them, and through the training, they gain skills that make them ready to go to work as interns or as permanent employees in the life science industry. They learn technical skills and professional skills and many other skills, especially in the biomanufacturing projects. They learn quality, compliance, documentation, and such. So next slide, please. So BioSCOPE 101, as I mentioned, that started out as the guidelines, it actually is a tool that provides you with a roadmap to how you would select and implement a supply chain project to use in a course, or use it in other ways too. You might use it in a biotech club, you might use it in a workshop. And for faculty who have experience working with supply chain projects, what we're looking to do is grow this out. We've started with 7 different projects, and we want to expand it as we get new projects. We have other projects we're adding that we're excited about, and Ying-Tsu will talk more about that. But we want to keep it interesting, whether you're new to biomanufacturing and supply chain, or whether you have a lot of experience and you're looking for something new to be able to do in your courses with your students. So the document is, it's actually not just a document, it's grown into a whole Canvas shell that offers several parts to it, which include document templates, and it has standard operating procedures, batch records, skills matrices, case studies, quite a few things. And there's an introduction to supply chain manufacturing as well. So, but I want to give you a little bit of background to the story, because especially there's quite a few people on the call from California. So many of you have been involved in this from the start, because this actually began with Baybeck, and with the biotech kits that they've manufactured and delivered to their customers, who are the high schools, many high schools in the Bay Area. And they saw this as an opportunity to have, instead of them manufacturing the components of these lab kits, why not let college students, community college students, manufacture these biotech kits themselves and get that experience? So that was the start of BioSCOPE. And they started with 3 colleges in the Bay Area, with Skyline College, Laney College, and Ohlone College in the original project. And it's expanded out to more colleges. And then I came along and had funding from the California Community College's Chancellor's Office to scale up a best practice in California. And this was a great best practice. And there were different versions of it being implemented in different parts of the state, but not all of the colleges were doing it. So I had funding to scale this up, and I gave out that funding to different colleges and programs that were interested in adding supply chain biomanufacturing. And what I discovered by the end of it, they were able to sort of work on curriculum and buy supplies and materials, and in some cases, small equipment. But it turned out that they kind of got stuck because the faculty that were new to supply chain biomanufacturing did not know how to really get started on it. So that led to the Supply Chain Guidelines Project. And then here we are now, because the Supply Chain Guidelines grew into BioSCOPE 101. So next slide, please. So we had a lot of partners that helped us, and just would like to acknowledge, we had industry partners and college partners, industry trade associations, workforce development partners. So it's been a wonderful community that's helped us grow this. And a lot of faculty have contributed standard operating procedures to this, and case studies, and those case studies have also come from industry partners. We had a lot of guidance from industry as well for what they're looking for. Next slide, please. So that basically brings us to the community of practice. And in order to do this project, we look to the biotech faculty who teach biotech and biomanufacturing, and their role in this, it would be practicing supply chain. Either they're currently practicing it or would like to in the future. We look to industry to find out what are the skills that they're looking for, and how could we design this program to make our students employable to those companies. And then there's our customers, and those are the recipients of our products. And mostly those are high school biotech classes. They're usually biotech kits that are developed but are produced. But in addition, they could be other kinds of customers. They could be other college classes, so college student peers. And they could also be customers in the community. Next slide, please. So that brings us to the skills matrix. We created a table of skills matrix because the whole point of this is to teach our students skills that make them employable. So as a faculty member that's looking to do a supply chain project in one of your classes or more, and you're likely going to start out with wanting to teach specific skills. So what we did with the standard operating procedures for the projects that we've started with in BioSCOPE 101 is we looked at all of the skills that are taught in each of these projects. And it turned out that there were quite a few skills that fell under multiple categories. So we created what we call the skills matrix, or the table, and we basically used an Excel spreadsheet. And we broke out all of the skills, and since they fell under so many categories, we decided it was kind of too much to have it all on one page. So we sorted and separated out those skills by type. So the example here in this slide are technical skills. So this list would show the technical skills that are taught in each of the projects. And then some of the other categories include professional or soft skills that the students would learn by doing a project, digital skills, quality and compliance skills. So we've separated those out, and you can't see it here, but Ying-Tsu is going to demonstrate that later. And she'll show you how you can go to different tabs to go to a different page. So if you want to look at the specific quality skills that the students would learn in a given project, you can go there. And it just simplifies it, makes it a little easier to find what you're looking for. So next slide, please. So now I'm going to go ahead and hand it over to Ying-Tsu.
Okay, thanks, Terri. It's really nice to be able to finally roll this out. We've been working on it for several years, I feel now, and Emily Kwok is really the person that we should be thanking for sort of putting all these documents into a place that teachers can easily access. So I just want to bring you to sort of thinking about supply chain biomanufacturing projects, or what we call BioSCOPE, in sort of taking a step back first. Looking at this project and trying to figure out what's needed. So I want to take you to some pre-planning first. And before I do that, though, I want to also acknowledge other people that's on this call. Mainly, I think Jan Chalupny is on this call, as well as Aaron Kamajaya, and others who have supply chain projects that you are doing already. And it's really nice to hear that other people do this type of project. And this is just, I just want to tell everyone, this is just one example of supply chain projects that can happen. Our version is BioSCOPE, and BioSCOPE 101 is our sort of guidelines or manual, and you might have other ways of doing this. So please, everyone, just know that there's plenty of supply chain projects out there. So before you start this project, we think that after like 5 years of doing BioSCOPE, we came up with certain things that you should consider before you start. And the number one thing is really customer. Who are your customers? Customers could be your own class. It could be your colleagues in a different program. It could be your high school partners. It could be a nonprofit. Contra Costa College works with a nonprofit called Urban Tilth that they do this project for, to do soil analysis. You want to also consider your facilities. The way that BioSCOPE is sort of practiced in the Bay Area is that it's done in 2 different ways. It's done as a club, and it's done in the classroom. If you're doing this as a club, you want to consider your facilities and see if you have access, for one thing. If you're done as a class, of course, you want to make sure that you have all the equipment and facilities as well. And I know for many community colleges, you have the facilities. We're hoping someday that high schools can also take this over. We have one high school partner in San Mateo that does a supply chain project with us. So you want to consider having the equipment and enough space to do a supply chain project, because sometimes you do need all that, a lot of room. So the next one is, of course, on a club. There's pluses or minuses in doing it in those ways. For example, as a course, you have funding coming into your course to, for teaching. And so you don't necessarily have to worry so much about funding. As a club, you might need that extra funding if you're going to be making special supply chain products for different partners. The next one is a coordinator. Consider having a student coordinator. This is what we do with BioSCOPE. We have found it very successful in helping faculty sort of do the supply chain management bit of this project. They can do inventory management. They can get volunteers or rally the students behind this project. If you're at a classroom, they can also prep for the teacher so that this project can go smoothly if you're doing this in the classroom or the club as well. They can also train other students. So the coordinators coming from Laney or Skyline colleges, they have gone through the BioSCOPE project in a previous semester or previous year. And so they know what's going on. And it also gives them another level of sort of understanding, because now they're in the part of training and teaching and supervising and really being a good peer mentor for the other students that are starting out with the biotech programs. And then finally, funding. It's always good to have funding, right? Finding a source where you can make sure that this project can be sustainable. And if not, then try to work with your partners to figure out how you can make this project sustainable. Before I go on to the next slide, if there's any questions, I think you can put it on the chat. And Sandy, please stop me if there's a question that you want me to answer right away. I'm okay with that. Okay.
Will do.
So, okay. So there's two things that that can help you with the pre-planning stage. And one of them is this supply chain process decision program chart. We always just call it PDPC. I can never remember the acronym anyway. It's a way of envisioning or visualizing what are the things that you should consider before you start this project. And I'm not saying that you should have all these things in place before you start. We know that's really difficult to do. It's just to keep these things in mind. And we got this idea really from Jim Hewlett, who actually does sort of this type of strategic planning with his group of teachers when they want to do the Curie project or the undergraduate research projects. So let me see if I can get a better view of this flow chart. So, okay, so I think I can actually enlarge it. So, so just following this graphic, we want to just start. And the other thing too, that we learned how to do these flow charts from one of our process development workshops. And we learned how to do this through Draw.io from the Google Drive suite of apps that you can use. So, another conversation that we should have in the future is our supply chain biomanufacturing hub and what that means to the community as well. Terri, myself, and Emily Kwok are part of that hub under the Innovate Bio hub system, or the whole leadership team. So just moving down in how you can start. If you want to start this project, what we always say is that you want to determine the type of quality that you have. And really, we don't emphasize this enough. Each one of our pre-planning and how you want to start a supply chain biomanufacturing project is to think about quality and how that's inserted into your projects. It really should be running through the core of every single thing that we teach as faculty in biotechnology. So you want to make sure about quality. And if you're unsure about how that works or what it means, we can also provide you with resources. We have had a really nice workshop with Vivian and Winward, who guided us with what quality means and how to insert that into your projects. We can always seek training in different ways. Terri is an excellent resource for quality. She is a big proponent. Every time you talk to quality, she always brings up quality. So, I mean, Terri, she always brings up quality. So just know that there's always someone there to guide you in that. The other things that you want to consider is think about your customer and what you're going to be making for your customer. A lot of times, the way that we work with faculty and teachers is what is the need What is it that you need that can help you with teaching a biotech lesson or teaching students biotech? So you want to determine, okay, what is the product that is highly needed? So is it just buffers? Is it auger plates? Is it different what else do we do? I can't think of agarose gels, for example. So think about the products that you want to make, and then think about your customers. Do they have a use for it, basically? If there isn't, or if there is, if you're unsure, just talk to us. We have ways to talk to you and ask you questions to bring out those different ideas, especially with your customers, if you don't have any ideas of who they may be. And we try to put that here too, so to jog your sort of your understanding of that. And then the different other things that we to consider, again, we have physical requirements, coordinator, and funding. Again, we are resources for that, since we are part of the supply chain biomanufacturing hub, or leads in that, so that you can always ask us questions. And that's what we're here for. Okay, let's see how I can go back to my slide deck. Actually, before I do that, the other sort of resource that we have here are the planning questions. If you're not a visualizer, we also have questions that you can answer to help you think about your supply chain project. So for example, how do you hope to embed your supply chain project? Is it through a course, a laboratory course, a boot camp? You want to think about quality and your customers. This is just a different way of sort of answering those questions that we posed earlier for sort of pre-planning on your supply chain projects, the products, etc. So it's a nice way to sort of think about the project before you start. One of the things that you might also think about are challenges. What challenges might you have for this? And if you have any questions, again, you can come to the hub, Terry, Emily, or I to answer questions, help you answer those questions. Okay, so I'm sure this is what everybody's waiting for, is how do I get there? How do I get to that BioSCOPE 101? So in order to gain access, we have written it here, and we're going to provide these slides to Sandy so she can also post it. So what I'm going to do now is take you through how to access it in real time. And the first thing you want to do is go through the BABEC website. And we don't mean it to necessarily just be in the BABEC website. It will be on Terry's website when that gets up. And we hope to have it somewhere in the Innovate Bio website someday too. Right now, it's just easier for the BABEC website because I can get it done quicker just talking to my team about it. You go to babec.org right here. You go to projects, NSF. You can read a little bit about all our different projects. I'm doing a little commercial there. Click on Innovate Bio. And then here is the link for the Supply Chain Biomanufacturing Hub. Click on that. And it gives you information about our hub. Okay. If you scroll down, you can see the projects that we have for the supply chain project, which I'm going to take you to the Canvas site. And then here are the 2 documents that you can access for pre-planning. And then finally, this is very important, is that in order to actually get access to the documents itself, you have to fill out this pre-survey. The reason is because we are funded by a grant. We need the data and understanding of why and how you're going to be using the BioSCOPE 101. So once you click on this, you can answer questions, very easy questions. And then when you click submit, you will automatically get a link to the Canvas site. And you will need to click on that link in order to get to Canvas. Okay. So Emily, Terry, and I, we decided that this needs to be easy for teachers to implement. So we decided that Canvas is the learning, what do they call it? The LMS for many colleges. So that's why we decided to put it onto Canvas. So many of you may know that Canvas, you can sign into Canvas even without a college, because right now I've been laid off from City College. I'm no longer a college instructor. So I can sign into Canvas for free with my BABEC email. And if you have a different email, you can also do that too. So you can click then onto, once you get that submission link, then you can get into this BioSCOPE 101, what we call a way to teach biomanufacturing. So click on that. And then you can then come up with all these different modules. And we think that Emily did a great job in trying to distinguish the different projects that's here, the aliquots, the broth, plates, agarose gels, et cetera, and trying to make this as easy as possible for teachers to implement. What you want to do is probably start here at the welcome. Here is where you can have an introduction to this project. And the other thing too is that they're all done as a Google document, spreadsheet, whatever you want to call it. Okay, so that's how you can get access. And you can also, what it does allow you to do too is to edit them. You have to download and upload again to your own Google Drive in order to do that. So going back to modules, there are information on for you and for your students that you can use for your students. And then there's some information about current supply chain projects, as well as some resources and quality introductions. So the thing that I wanted to take you to right now to start is the skills matrix for each project. So if you click there, then you can get to the skills matrix that Terri has already talked about. And I want to get to a much more easier way of, bigger way of looking at it. So this is the spreadsheet, same thing as what you just saw. And what Terri talked about are these different skill sets that we have delineated. And again, this came from a community of practice. So faculty had input in this as well as industry. And from that, we came up with these different projects for this BioSCOPE 101 and different inputs onto what these technical skills and other skills are needed for. If you look at just the technical page, you'll see that there's a lot of different skills, right? And, we have had some input saying that why don't you combine some of those? And the reason we are really making this granular is because we want to make sure that faculty and teachers understand that these are sort of granulated skills, right? And that students can also understand, oh, I'm doing a aseptic technique. I am learning how to properly store reagents and products. So all these are also helpful for looking for sort of job descriptions, if you will, when you're looking for jobs. And they're also there because all these different projects are focused on all these different types of skills. So we have groups of people that do, say, for example, aliquots, check off or even give us what the skills that they work on for that project. So that's where the check marks come from. If you're working on agarose gels, those folks that came up with this project checked marked on the skills that they do for this project. And as you can see, histology has sort of different technical skills further down, as well as analysis, right? So as a faculty, how you can use this is that you say, okay, I really want my students to learn how to do lab math, okay? What projects can I use to teach my students lab math, okay? That's one way of using it. Another way of using it is that, okay, I have a customer who needs plasmids, okay? So if I'm teaching this to my students, what can I tell them? What can I put in my learning objectives that they'll be learning when they're learning how to do this plasmid extraction? Okay, and these are all the things that you can talk about with them. Okay, so that's the technical skills. Let's go on to the next tab, which is quality. And you'll see that every check mark is pretty much there, right? It's because quality, again, should be part of our backbone for all the different things that we do in biotech. So, example, in documentation or in batch records, those quality checks are inserted in this and using kappa or using fishbone when you're figuring out if there's problems. So this is another sort of skill that we that also the community of practice told us was important. The other sort of skill here is professional skills. And here you'll see that there's some dark check marks as well as lighter gray check marks. Those dark ones were the ones that the groups, the faculty in each group sort of checked off. And then the gray ones, we put them in ourselves because, as you know, all these skills, they're needed by every single project pretty much, right? We really emphasize professional skills in the way that we teach biotechnology. And so even though the faculty did not check those off, the ones that they did check off are really emphasized for those different projects. I hope that was not too rambly for you. The digital skills are really things like doing inventory management, using even an Excel spreadsheet is useful. Some colleges are now using electronic lab notebooks. I know of a college that's trying to do more project management. They're using Kanban boards or Asana to try to work out management with each other. LIMS is another one that's really good for the students to know. So these are also other skills that we think is important for your skills and how it matches up with these different projects. And then finally, safety. Of course, safety is very important for all our biotech. It's sort of a given, right? We need to know about safety. And then the last one is sort of these job search skills. One of the first things that I said earlier was that in learning the technical skills, it's good for the students to understand and call out, articulate what they are learning. I find that, working with as mentors for high school students, for college students, when I was teaching at City College, they don't necessarily know what they call what they're learning. And it's good to always articulate that with your students. So something that we find that's very useful for that teachers have told us is that it's also helpful to teach your students those job search skills. And throughout your teaching of biotechnology and using those projects, you can also talk about how to search for those projects. Supply chain management is, we're starting to hear more about it. It's always been done, right? But now it's become very popular. And of course, you can also have biotechnology supply chain management. And you've heard about all the cold supply chain management that has to be done with the COVID vaccines. And if you look at industry now, there are jobs called supply chain management. And it's a very nice high-paying job. And if it's going to be focused on biotechnology, that's what we want our students to get at. And that's what is trying to sort of widen this ability of our students that are learning biotech. They can go into the lab as research, but they can also do supply chain management. So it's giving them more options. Okay, that's enough of that. I'll go back to the Canvas site. So now what I want to do is, let's see, walk through one of these projects with you. Okay, let's see what these other ones are first, if I'm not forgetting anything. Okay, so I want to take you through this Luria broth plates as a project. And I'm taking you through this because Laney and Skyline are just incredible for us. Last year, they helped pour over 9,000 plates for us. We have a lot of high school partners. There are really, BayBec is their customer. BayBec also has customers, and those are our high school partners. And believe it or not, plates and availability of plates is one of the barriers to high school teachers doing biotechnology. And of course, they love doing the bacterial transformation because the students get to see color. And so this is one way we can help them with teaching biotechnology and increase their confidence and comfort in teaching biotechnology in the classroom. So just taking you through the Luria broth plates, I'm going to click on that. And you'll come to a page of slides. So again, we're trying to make it easy for you. So you can go through the slides and sort of introduce this project to your students in this way. And Emily, what she has done is taken you through how this project is done by first validating the balance. Okay, aside, I don't come from industry. And so, I knew how to calibrate an instrument, but I didn't understand what validation meant. Okay, so I have learned a lot through this BioSCOPE project and how to calibrate and validate that balance. And so it's also a nice thing for your students to know too. And I've seen the coordinators at Laney and Skyline teach other students on how to calibrate and validate the balances before they start their project. So it's a really nice thing to incorporate. And you can see that you can make the antibiotics and then make your LB media, pour the plates, and then test the plates for quality. And then throughout all this too, you're checking for quality in every step of the way. So that's just an example of how, of what you can sort of introduce your students to before you do this project. So you can talk about the technical skills and all the different other skills that we had on our matrix. And then here, we're really trying to go towards more flowcharts. I hope that a lot of you are doing flowcharting in your classroom, and for a visualizer student, it helps them in sort of see what they have to do and sort of the big picture, right? They know that they got to pour plates, but what's all the little steps too? So that's what this is for. And again, all these things can be edited by you. If you don't agree with this, you can go ahead and edit yourself. Here's more information, okay, and the process for pouring plates. So the other bit that is pretty important that is super incredible that Emily did was to make standard operating procedures for each one of these little steps along the way. For example, I don't know if it's not that big here. For making ampicillin, there's an SOP for that. And we can see what it looks like. Oh no, this is the safety sheet. So sorry about that. I'm gonna go back to that. And I'm gonna go back to this. Okay, so SOPs for, oops. Making, so for example, LB auger plates. So this is what it looks like. You may, we got this, we got a sort of a template from one of our several of our faculty members. And what Emily has done is that she's incorporated what they've suggested into sort of a template SOP. And this is what we've come up with and how you can use that SOP. And again, you can download it, change any one of these procedures at will. You can also see there's documentation here and for that, and it's as well as safety. So that's, let me go back to say an SOP for pouring plates, and let me see if I can get this to open up. Maybe not. I just wanted to make it bigger, but I guess I can't do that right now. My technical skills go out the door when I'm on a webinar. So so as you can see, there's things for the students to do to make sure that they can check off as they go. And it's really a way for the students to sort of look at what they have to do in terms of procedures. The other important thing about each that we try to do here is to provide batch records. And this is just an example of a batch record. So so here's another bit about me that you may not know. I had no idea what the difference between an SOP and a batch record was when I first started teaching biotech. I didn't come from industry. And so this kind of also gave me an idea, and through a lot working with NICAP, what the batch record has to say. So for example, if a student was making LB auger plates, it's good to work as a pair. So once the technician, once the verifier. So as you are checking the balance, for example, the technician would initial off to make sure it's working properly, and a verifier would do the double check. It's especially important when you are putting down information like recording the lot number. The technician has to initial and the verifier has to initial. It seems, for a person that came out of research, it's like, oh my God, that's super tedious, right? But that's what industry standards are, and industry wants for the students to know how to do documentation. And so it really helps them get into that groove of documentation. So again, this is a way for you to use this just as is, or you can download and then upload again onto your Google suite. So that's kind of what a batch record looks like. You guys probably know better than I do. So let me say a little bit about the different projects that we have. We have aliquoting, and you may think, oh, aliquoting, everybody knows how to do that. It's really a great way for students to learn first off, just because it's one of the first skills they need to know. And for us, for some of our BioSCOPE projects up north in the Bay Area, aliquoting chelax, which is these little beads for DNA extraction, is actually very difficult. They have to make sure they're using the right equipment, that they're using a wider bore tip, like a blue tip with that's cut off. It's really a good way for students to understand the importance of aliquoting correctly and doing quality checks to make sure the beads are in every single tube. And you can see here, there's also other aliquots for, like, say, buffers or calcium chloride. And partly it's because as BABEC, we need calcium chloride in like 30 mils in a 50 mil tube. You know, all these things that you got to consider when you have partners is like, how do you want this done? How do you want your product done? Is it in a 50 mil tube? Is it in a 15 mil tube? Is the volume 50 mils? Is it 30 mils? Right? So all these different aspects that you got to work with. The other bit too is about labeling. Like, how do you want it labeled? As BABEC, we work a lot with high school teachers, for example, that we don't want sort of expiration dates on them, even though that's part of what industry wants. And so this is something that we talk to our producers about, because our high school teachers freak out if they see that the expiration date is passed. You know, but for our stuff, it's not like, you know, it's not like food or something. It really is pretty robust. The other bit that I want to also point out is tell us what you think. So we want comments. If you're using this and you're finding some things aren't working correctly, or we made a huge boo-boo somewhere, it's good to tell us. We would thank you and appreciate you if you tell us what's going on, even, you know, good things and bad things. So you can click on that and just comment on it. And it's also a place where you can also talk to each other, I believe, on here. Like if you have a question and maybe we can't get to it, Emily can't get to it, or I can't get to it, or Terry can't get to it, maybe some other person in the community can get to it. It's a really nice thing to just have a discussion going. Okay. So we have 7 projects so far here. We have those aliquots and LB plates, agarose gels. I believe Joe Wu's college, they pour agarose gels for their high school books. PCR, just a template. You can use it for your own, you know, for what you want to do. Bacterial transformation, protein purification. And the one that I think a lot of people are very interested in is this Taq polymerase, sort of isolation. It's not purification because it is used in a crude sense. So Emily right now is working on that one. We also have histology slides here. Oh, actually, before I go on, Taq polymerase, if you want to use this SOP or this project, DNA LC has given BABEC the plasmid and the streaks, so we can send it out to you for free. Okay, just let me know. Okay, the other one here is case studies. So case studies, we thought, is a really great way for students to learn professional skills, sort of situations in the lab, right? And so we had another workshop where some faculty members contributed to some case studies. We had a template that was made by, I think it was Lori Eiseltarber, and then both her and Shabash really worked on some case studies for us. So their examples are here, and you can see that there's some templates that you can use to help you write your own case studies on here. Okay, so that's that example. And then another example that I love, process maps. So this was another sort of outcome of a workshop that we had, and you can learn about process maps here. And it doesn't look like Emily put the nice video that Kathy Harker made. I will make sure that we put that up. But this one, oh, here it is. Great. So this video Kathy made from Citrus College on how to use the Draw IO that's available for free on the Google Suite. So that's that. And, you know, I will say, I'm going to stop share now. I will say that, you know, this is an iterative process. This is not the final. It's very drafty, and it really hasn't been part of like teachers haven't really vetted it enough yet or at all, right? So if you guys are trying it out and find things are working well or not well, you know, that would be great for us to know and for the team to, for the community to know. And so your input is definitely welcomed here. I think with that, I'm going to stop now and take questions.
It's a great talk, Ying-Tsu and Terri. You guys have put, I mean, a lot of other people too have put so much work into this. So I think this is going to be, it's a really wonderful resource.
Can I make a comment before we go to questions? It's something that I'd like to point out. I think everybody here and everybody watching this is experiencing problems with enrollment in the biotech courses. And we see as a huge opportunity here to seek out high school partnerships and seek out high school biology and biotech classes to become your partners to help create pathways into our programs. So we're extending the pathway down to K-12 and to students from high schools that could come into our programs and then get employed. As you know, there's also a huge supply gap in employing the biomanufacturing jobs. So we're really trying to encourage people to seek out partnerships with your local high schools if you don't already have any. And even just bring on one partnership, you'll be reaching so many students that way and building pathways into your classes.
Thanks, Terri. It's a great observation. Very good point. Are there questions? Oh, I guess there was, okay. There was a question that kind of came to me as a direct message, but I think I'm going to actually ask this to Ying-Tsu and Terri because I don't know the answer, which is somebody accessed the Canvas site and there was a message to contact somebody switch from student to teacher.
Good. Yes, I didn't get to all that. So you're going to be inputted as a student, okay? And we can switch you to a teacher. But really, it doesn't really change much in terms of you can't edit any of those documents, even as a teacher. You're just going to be able to sort of download it as a teacher. And we have all those information in the slides that I didn't go over. What you can do to edit it is that you're going to have to download it. Even as a student, you can download it and then re-upload it onto your own Google Drive. It's kind of tedious if you're going to do all 8 projects, right? So you probably want to just start out with one and see how that works for you. We can also try giving you access in different ways to make it easier. And we'll have to talk about that as a team on how we can do that. But when I'm not very well versed in Canvas, but when we asked Emily about that, she says, yeah, you're going to have to download each one if you want to make any changes. But for now, as getting in as a student, it's going to be very similar as a teacher, right? But once you get in, we can switch you from a student to a teacher very quickly.
So do they need to just email you, Ying-Tsu, to ask for that?
So Emily has just been doing it right off. You know, if you come in as a teacher with we know you're a teacher, a faculty member, then we just switch you to a teacher mode.
Okay, because somebody commented that being in as a student mode, you don't see the behind the scenes things like TAC polymerase, for example.
Oh, okay. So TAC, you know, it's an under construction anyway. So we're still working on that. And yeah, thanks, Terri, for thanking Aaron, who is here, and Bruce on that project for Aspire for TAC polymerase. You know, DNA LC has this awesome plasmid called Simple TAC that you can isolate TAC polymerase from, and it works pretty well. I mean, it's, you know, to me, it's like, oh, it's kind of dirty, but it actually still works. It's a crude extract of TAC polymerase.
Yeah, sorry, it's more than a little dirty, right, Aaron? But you know, nearly boiling things kills most of the stuff, and TAC, and I'm guessing RNase is in there too.
Mm-hmm.
So it's sort of, I wonder if it's actually if you could get rid of the TAC if you had a good RNase prep too.
Mm-hmm.
But
Well, I'm hoping if some faculty that's here that does sort of protein purification, Bob, Dominique, if you can actually purify it, that would be great. That's another
Aaron's
Come
project.
up with
Yeah.
another supply chain project.
Yeah.
And which, by the way, we would love, this is for you, but this is kind of a two-way street. And what we would love to hear from you, Ying-Tsu pointed out your feedback, but also, many of you are experienced with supply chain. You have your own projects, more than those that we have. And we would love to take on new projects and add them to this to become a national resource. So if two things, if you have other projects that you would be willing to share with us and share with the whole community, we would love to have that. And the other thing is if you're once you download these projects, if you are going to modify them to suit your needs, and you could have a better way to do something, or you discover something new or have something else to add, please share that with us. We want to know if you can improve upon what we have. We would love to get that feedback as well, in your own way of teaching these. But of course, we have to stick with the quality and compliance. So, if you're not into doing quality and compliance and you pull it out and you say it's much better without it, that's not what we're looking for. So,
Yeah, don't tell Terry that. She doesn't
yeah,
like it.
but please share any improvements or upgrades that you think of for these projects, because it will expand this resource. It will help us expand the resource.
I think Jan might have a couple comments on that.
Hi, Jan.
Hey, Jan.
Hi. Yeah, what a great presentation and so many cool resources. OMG. I really want to share these with high school teachers in this area who are in the process of planning a second-year biotech course where they would delve into biomanufacturing. We've got the kit. You can make that kit probably last like 6 weeks if you're, really take time with everything, but that doesn't fill a whole year. And so all of this supply chain curriculum could be, it just dovetails perfectly, and their students could learn so many things, if they include this in their curriculum. So I'm going to share it out to all of them, as well as the faculty at Shoreline. We do a little bit of supply chain type stuff where classes at Shoreline create some of the reagents that I use in the kits that we supply through our kit loan program, which include the Amgen Biotech Experience kits and also some kits that we've developed. But it's very informal and not very structured. They do their own kind of batch records, but they're way more informal than a true industry batch record. So I'm hoping that we can add some of this curriculum into our current courses, just to, students would learn a whole bunch of extra skills, and we'd have some more quality control done on those reagents that I supply to teachers to use in their classrooms with our kids. So I have plans, and I love all of it.
I think the high school, we actually work with a San Mateo High School biotech program, and the students just love making something that they know is going to go somewhere else, right? They just love that idea. So it's really a big plus. I think they're even more excited than the college students in making products that go somewhere. The other big thing is that if we're calling it biomanufacturing, we really need, we find here, I know my partners in the Bay Area, they don't know, the teachers, high school teachers don't know what biomanufacturing is. So if we're showing them an example of it, a really simple example, right? We're not talking about bioreactors necessarily. It's a very simple example of what manufacturing can be like in industry. I think it's very helpful too, just to get them in that mindset.
Yeah, I discovered that too, just trying to get a group of teachers to advise me as I was setting up or developing the curriculum for the biomanufacturing kit, that their first question was, what's biomanufacturing? So, people still don't really know what biotech is. Of course, biotech teachers do, but these are teachers who've been teaching biotech for 10, 15 years, and biomanufacturing is newer, and they did not know what it was.
At the end of the day, though, it's what biotech is really all about. making products. If you don't make products, you don't stay in business. And by the way, there's another term that is starting to get used for biomanufacturing as well, which is bioprocessing. And so when I look at jobs and I do job searches, it's about half and half. On the East Coast, it's a little more bioprocessing. On the West Coast, it's a little more biomanufacturing. Before we can take, I think, one more question, but before we go, I wanted to point, oh, there is a question here too, but I want to point out I've put links to the evaluation in the chat. So if you could please click that and fill that out. And then we have another question about the skills aspect, which is, has there been any discussion with industry in the area about micro-credentialing for those skills? And I'll let Terri, why don't you take that one?
Yeah, we did discuss micro-credentialing, and in fact, we work with Angela Consani and Heather Seats of the Bioscience Core Skills Institute. So it is an aspect that we want to integrate, and we did get industry interest. We had a discussion about it, but that's kind of as far as we got at this up to this point. So we do know that there's interest, and it's something to definitely expand upon and build out more micro-credentials for this, because those will certainly help our students be able to have something that validates their skills on their resume. So yes, that has been a part of the discussion, and it needs to be continued.
Okay, and let's see. And there's the Ying-Tsu has put links to the BABEC website and stuff in the chat that you can find. Any other questions or comments?
So I had a question. Sandy's survey here is for this webinar. Okay. The pre-survey that I've been talking about is how to get access to BioSCOPE 101. So if you want to do that, then just go ahead and click on the link that I provided there. If you don't want to go through our BABEC website, of course, you can go through our BABEC website and learn who we are, blah, blah, blah. But if you just want to get to that pre-survey, just go ahead and click that longer URL.
And the instructions are on slide 13, and Sandy is going to be sharing the slide deck with everybody. So you can go back to the slide deck and easily find that slide, and that has all the instructions that'll help get you there.
So you'll just email the slides to me, right, Ying-Tsu?
Yeah.
Okay. Then yeah, I'll make a PDF of it and then post it when I have with the video.
So Sandy, I think it's fine to just provide the link as a viewer. We don't, I think it's because if we make any changes, if people can see the changes then right away, instead of us having to send you another PDF.
Whatever you like. I can post a link on the webpage too.
Okay, thanks.
Yeah, that would be the easiest thing to do. I think that would make life easier for everybody, since it's sort of a roundabout way to access the pre-survey that gets you into the Canvas site. But once you're in the Canvas site, you don't have to do that again. You get access, once you're in the Canvas site and download it to your Canvas site, you get access to it, and you access it just directly through your own Canvas site.
Any other questions? All right. Well, just one more reminder about the evaluation. And thank you, everybody, for attending. And I hope to see you all December 2nd when we talk about all the program pages and we talk about the data that Innovate Bio collects and how you can make the best use of it. And have a great weekend.
Thanks, everyone. Thanks, Sandy.
Thanks, everyone. Thanks, Sandy. Thanks, Cassandra.